5, more proportions in triangles. If you haven't noticed, we're doing a lot of proportions this chapter. There is a theorem. It's called the Side-Splitter Theorem. It splits the sides, not equally, but it splits them. And it says this: if a line is parallel to one side of a triangle and intersects the other two, so it's parallel but also intersects the other two sides of the triangle, then it divides those sides proportionally. Okay, so what they're saying here is, if we look at this picture, they're saying BD will be parallel to AE, and you have to know that. If the lines aren't parallel, this doesn't work, okay? But because the lines are parallel, what we're gonna do does work. So what it says is, if AE is parallel to BD, like we see in the picture, then we can say AB over BC. Okay, so notice it's cutting it into two parts. This part over this part will equal, any guesses?
The other part.
What part? Give me letters.
CE, DE.
Not CE. So if it was AB to start, what's it going to be over here?
Oh,
ED or DE over CD or DC. You can write those in any order, doesn't matter. So you're setting up a proportion because the lines are parallel. Okay, since the lines are parallel, then the parts have to be proportional on the sides of that triangle. Okay. This next part is just a proof of why. I don't expect you to do this proof on your own. This is just me talking you through why does this thing work. Okay, so don't freak out about a proof. It's not, you don't have to do proofs. Here's why. It says, given triangle QXY with RS parallel to XY. So you need to mark that parallel. Okay. Prove that XR to RQ equals YS to SQ. We're just doing a proof of the side-splitter theorem. Here's why side-splitter theorem works. Okay. So the first one is what? Given. Should have spaced this out a little more. Sorry. Okay, now you need to write some angles in. Here's the other place that I didn't get all of my stuff written in. Angle X we're going to call 1. Angle Y we're going to call 2. And then we're going to call these 3 and 4 up here so that we don't have to name them with 3 letters. We can just name them by their number. So angle 1, angle 2, angle 3, and angle 4. Okay, this says we know that angle 1 is congruent to angle 3 and angle 2 is congruent to angle 4. How do I know that these are congruent?
because of the side splitter.
Not because of side splitter. We learned this in chapter. Close. You're on the right track. You're in the right chapter. Corresponding. Those are corresponding angles, right? When lines are parallel, then corresponding angles are congruent. You can just write corresponding angles for me. That's fine. So same here, right? Those two they said were congruent. So then how do I know that QXY, the big triangle, I lost my Y, is similar to the smaller triangle? Look at your markings. How did we prove triangles similar? There were 3 theorems. This would be AA, right? This is AA similarity. So we know those 2 triangles are similar because of AA right now. So if the triangles are similar, this says XR to XQ. What? Ugh, that's wrong. Why did it do that? It keeps doing this. I know what I'm doing.
What are you doing this
Shoot. When I copy an equation and I paste it and I edit it in the pasted one, it's changing the old one too. Noted. That's happened twice now. Okay, you need to change this. Sorry. Apparently don't copy and paste is what I'm hearing. This should be XQ on top. Here, I'll write it here. XQ to RQ equals YQ, oh no, to SQ. I just typed it wrong. So it's not happening that way. Well, that's good to know. I typed it wrong. It's XQ. So they're saying, how do we know this to this equals YS, YQ, sorry, the big one, to the small one. So how do we know when the sides are similar, how do we know those side lengths are proportional? For that reason. We know that if triangles are similar, their sides are proportional and their angles are congruent, right? So you just need to write something that explains that. Just say like sides are proportional in similar triangles. Right? The sides have to be proportional if we proved the triangle's similar. Okay, then this next one is from like chapter 1 here. It says XR plus RQ is equal to XQ. So this little piece here plus this little piece here equals the whole thing. Do you remember which one that was? Which postulate? Segment addition postulate, right? You add the two pieces together, you get the whole thing. That was segment addition postulate. Okay, so if that's the case, now look at what happens. What was XQ up here, we are going to turn into XR plus RQ, because we just said that those things are equal. So we're just substituting something that we know is equal to something else. So that's substitution. And then the last step, and this is one that you're not going to use a ton, but it is true. We went from this to this. Do you remember properties of proportion said we could do the sum, numerator plus denominator over denominator? It was the first question on your last quiz, right? So that's how we know, just properties of proportions, that will be true. Yeah, they should be in. I think my TA put them in during second period today. I don't know if she got yours in. She got most of them in. So that's why Side-Splitter works, okay? It's a process. Good thing you don't have to go through that process every time you use Side-Splitter, right? This is just saying Side-Splitter will always work, okay? So let's look at an example of it. In this setup, we are going to say something over something equals something over something. We're setting up a proportion. What's that going to look like? Here's my parallel lines, right? So which two form the ratio? 12 over what? X plus 1. It's the two that are on the same line that you make a ratio, okay? Now here's the beauty of proportions. If you were to do 12 over 9 equals x plus 1 over x, you'll still get the right answer. It's not technically the right setup, but properties of proportions lets you switch means, which makes that correct too. So you have a lot of ways to do this right, even if you're not doing it right. But what you should be doing is 12 over x plus 1 equal to 9 over x. Okay, so the two that are on the same line set equal to the two that are on the same line. Just make sure that if you go 12 over x plus 1, you cannot go x over 9, right? You got to go in the same order that you started in. What do you do to solve that? You cross multiply. So it's going to be 12x equals 9 times x plus 1. You'll distribute, so 12x equals 9x plus 9. Take away the 9x. So 3x equals 9, and then divide by 3. So x should be 3 there. Okay, and you can always plug it in and check. If I make this a 3, 9 to 3 equals 12 to 4. right? 9 over 3 does equal 12 over 4. So then you know you have the right setup. Okay. Questions on that? All right. Next one. There's a little add-on, a little corollary to the side-splitter theorem. And we're going to draw this together because this is one of those places where I just didn't have enough time to get it drawn in. You're going to draw 3 parallel lines, but don't space them equally, okay? So parallel lines, and then we're going to do a transversal here and another transversal here. We're going to call this line A, line B, and line C. And then we're going to letter all of our points of intersection. So A, B, and C over here, capital now, and then X, Y, and Z over here. Okay, so the side-splitter theorem said the sides of your triangles are going to be proportional pieces, okay? Well, now we don't have a triangle, but we have the same concept. We have parallel lines and 2 lines, they're not sides of triangles now, but 2 lines that are cutting through our parallel lines. Those sides are going to be proportional. So here's what the side-splitter theorem says. It says if A is parallel to B, which is parallel to C. So if the lines are parallel, okay, then it will still work that the 2 segments that form the same line will be proportional to the other 2 segments. So we would say AB to BC will equal XY to YZ. Okay, and if you notice, on the side-splitter theorem, I went from the bottom to the top, bottom to top. This one I went top to bottom over top to bottom. It doesn't matter, right? The properties of proportion says you can take a reciprocal and you'll still have an equal proportion. So just make sure that whatever order you do it in the same order on the other line. So if I'm going to go AB over BC, then I have to go XY over YZ. But if I want to go BC over AB, then I'm going to go YZ over XY. Okay? Questions on that? Okay, let's try it. So it looks like this. Can you set up a proportion for me?
X over 62 equals 70 over 56.
Right, and where you need to be careful again is don't say X over 62 and then go 56 over 70, right? Go in the same order. So if I'm going left to right here, go left to right up here. So it's going to be X over 62. So it's the 2 that are on the same line. And then 70 over 56. And then you'll cross multiply it. Okay, so 70 times 62 is a large number. So we get 56x equals 4,340. And then you're just going to divide by 56. And you get x is 77.5. Okay? Questions on that? Last one. So this is a different theorem, but it actually, if you follow the same rule, it's pretty much the same idea. Now instead of drawing a parallel line, now we have an angle bisector. Okay, so this line AD here is bisecting angle A. When that happens in a triangle, you get proportional parts again. And if you can just remember the rule that the 2 that are on the same line form a ratio, you'll be good, okay? In this case, what it's saying is if AD bisects, okay, so you have to know this. So if AD bisects, angle A, then it will always be true that notice what happens here. CD over DB. So the two that are on the same line, CD over DB, will equal, what's your guess? If I do CD over DB, where should I go next?
CA.
AC or CA over what?
Over AB.
AB. Okay, notice you cannot do AB over AC, right? If we're starting on this side, go to this side, then I need to come back to that first side. Kind of think of it as two separate triangles there, I guess you could say. Go back to that first triangle that you used a segment on. Okay? So how would you set this one up?
X over 9. 25 over 50.
That will get you the right answer, but no, that's not the right setup. But it will get you the right answer.
X over 25.
Yes, so you want the two that are forming the line to be making the ratio. So 9 over 15 equals X over 25. But notice what he first said, right? X over 9 equals 25 over 15. When you cross multiply those, you get 15x equals, what is that? 225, both ways, okay? This is technically not the right way, but by properties of proportions, you're still gonna get the same answer. So set up the things that are related to each other, 9 to 15, x to 25, cross multiply, so you get 15x equals 225, divide by 15. What's 225 divided by 15? 15. Perfect square. Okay, so two main theorems, the Side-Splitter Theorem and the Triangle Angle Bisector Theorem. Both do very similar things. So set up a proportion where the two that are on the same line form a ratio. Okay? Good? No? Where are you not good? Oh, good.